close this real quick.
All right.
Hello, everyone. Thank you for joining us this morning, 8 o'clock Mountain Time, May 27th, 2020. Today we'll be talking about surveying NATM tunnels, which is new Austrian tunneling methods, with this TBC Power Hour. Next slide, Riley. The presenters today will be myself, Jeff Ryan, Product Manager for Trimble Business Center, and then we'll also have Riley Smith, the Tunneling Applications Engineer here in Westminster, Colorado. Thank you for joining us today, Riley.
No problem. Glad to be doing another TBC Power Hour. It's been quite a while, but I'm excited to present.
All right, so today's agenda, we'll kind of give an overview of tunneling construction as a whole. Then we'll go over new Austrian tunneling methods, otherwise known as NATM. And then we'll also go through survey workflows and solutions. We'll give a demonstration on Riley's end, and we'll quickly discuss resources, and hopefully we'll give a lot of time to answer some of your questions here at the end. And I'll let Riley talk to that awesome image that he added into the agenda.
Well, just to set the tone that we're going to be talking about tunnels today, and so feel free to ask any questions, or if there's anything specific that you want to know about tunneling or tunnel surveys or any of the Trimble tunnel solutions, feel free to put that in the chat now, and we'll try to get to that over the course of the next hour.
Awesome.
So
Thanks,
before
Riley.
we dive into an overview, I think we're going to throw up a little poll for everyone. If it hasn't been already up. And this was, have you ever performed tunnel construction surveys? So just getting an idea for all of those of you who are on the line, how many of you are familiar with kind of what surveying in a tunnel entails and some of the challenges and so forth that are involved? So it looks like so far we've got a decent spread. About 41% have surveyed in tunnels, but not very often, which to me makes a lot of sense. They're quite large projects and maybe not as prevalent as your average cadastral survey or your average site construction survey.
I'm going to go ahead and hide it.
Cool. All right. So I've got myself on webcam, so hi everyone, and I've got trusty Total Station in the background, which we're going to be using today. But first, we're going to go over a bit about tunnel construction, and then talk a little bit about what NATM tunnels are and the surveying involved. So let me dive into the slides here. So why do we build tunnels? Well, there's really three categories of tunnels. There's for transportation, public works, and mining. So in transportation, this is all about moving people by road or by rail or metro. In public works, this is more about moving resources. How do we get things like water, wastewater, utilities, oil? How do we move those things around? And then in mining, it's all about resource extraction and moving that material in an efficient way. And they all have their different types of challenges and needs, both from the construction, design, as well as survey perspective. Now let's look at some of the tunnel construction methods. Now this isn't the most comprehensive list, but kind of trying to nail down what are the kind of most prevalent methods used in the industry. And they really depend on, is it underwater or is it on land? And then from there, we look down into kind of three broad categories of immersed tunnels, mined and bored, and cut and cover. So the two on either side, immersed is when we're taking essentially prefabricated segments, floating them out to an area and submerging them to the seabed and then covering them up. Why it's called immersed. Cut and cover is where we're going from the surface level and cutting down to where the tunnel will be and then backfilling after that tunnel structure has been created. Typically quite prevalently used, but getting less and less because of the environmental impact that's required to build that tunnel. And then we'll look at the mined and bored. So three categories. The first two are probably some of the other most prevalent methods used. The left-hand side is the NATEM and sequential excavation method, and that's what we'll be talking about today. And then in the middle is the TBM or tunnel boring machine method, one of the fastly growing and popular methods of tunnels, and as well as pipe and box jacking, which is used a lot in microtunnels and smaller diameter tunnels. So getting into the NATEM method, or the new Austrian tunneling method, also referred to as the traditional method. So it's a combination of drilling and blasting and excavation to create the tunnel. And so this can be through a variety of means, but I'll kind of go through the general process, which is starting by marking and drilling out the holes in the tunnel face for the charging, detonating those charge to break up the material, ventilating, so getting rid of all the dust and debris so it's safe for people, excavating that material, so that could be removing material by loader or other means, typically called mucking in the slang term. And then there's installing temporary support. So this could be the arch, the ribbing along the side, usually surveying for the next section, so understanding the geology as well as how much material has been removed, and then reinforcing, usually by shotcrete, rock anchors, and a variety of other things. And then this is repeated every so many meters, depending on the geology and the surface. So it could be every meter that we have to do this process, maybe every 5 meters. So it's very iterative process. Next, we're going to look at the workflows from a survey perspective that are used in tunnel construction, specifically in NATEM. And there's other things, I'll kind of generalize these into categories. There's other things that are involved, but I would say one of the most important categories is the geodetic and control survey. So typically starting from outside and going into the tunnel. So outside, it might be using GNSS static at each ends of the tunnel to establish a good baseline for the control. And then as the construction progresses, we're going to move the traverse network into the tunnel and following along with the construction process. And this is I would say, a quick, timely, and important process that needs to be performed. And there's multiple ways of this done, and especially trying to maintain accuracy over long distances is a big survey challenge, and some of the different ways that that is done. Next is, once the kind of the tunnel is started, we've got the control network established up at the top. Now we start to do the drilling and blasting, and as well as measuring how much material is being excavated. So this is guiding the drilling jumbo to drill and where to charge in the face of the tunnel, as well as collecting data on how much material is removed and helping the shotcrete crews and the reinforcement crews to put those rock anchors in and the proper amount of shotcrete. And another key part of well, really any tunnel is deformation monitoring. So this happens both in and outside the tunnel. So outside the tunnel, this is about understanding and alarming and reporting to the necessary stakeholders all of the key infrastructure that is around and above the tunnel. So this could just be as simple as understanding, is a building moving while the tunnel is being bored underneath. Inside the tunnel, this is more about understanding the shape of the tunnel after it's been excavated, how it's deforming at key points. You see on the right-hand side there, I've kind of noted out some reflector targets that are on the side of the tunnel. So those are measured in a campaign-based style monitoring and checked for movement relative to each other to understand, okay, is the tunnel collapsing in here, maybe at the bottom towards the inverts, or at the top, and getting a better idea of that movement. And then the fourth category, fourth and final, is more of the feature staking and the kind of final as-built. So what is that tunnel actually for? Is it a road? Okay, so then we're building in the sidewalks, any drainage, we're putting in the asphalt, and all of the necessary things to essentially finish off the tunnel. It might be utilities overhead and ductwork, a variety of different things. And this is where we see more and more scanning, 3D laser scanning being used as well. So with that, we're going to go into a demonstration. So first, I'd like to cover about what the demonstration will include. So first, we're going to start in Trimble Business Center, where we're going to use the tunneling module to essentially do data preparation and kind of prepare our design for going out into the field. And then in the field, so transferring that design can kind of be through a few different methods. It can be using Trimble Sync Manager, or it can be kind of through the classical methods of a USB email to the data collector kind of approach. So once it's in the field, we're going to be using Trimble Access Tunnels and the S-Series total station. In this case, I have an S9 total station. And we're going to first review the design and make sure that everything that came or was in TBC came into Trimble Access. We're going to do the setup of key points, so for rock anchors, blast holes, that kind of information, as well as machine positioning, really useful for drilling jumbos. And then we'll do an auto scan, so how do we collect profile data for understanding the volumes in a more automated fashion, and then some in-field reporting as well. And then from there, we'll take that data and we'll transfer it to Trimble Business Center tunneling module, where we'll do an as-built analysis, so kind of more of a complex understanding of what data has been collected in the field, and overbreak and underbreak reporting. And then if we have some time, we'll also get into some cross-section and sheet creation. So with that, we're gonna go into the tunnel. So give me 1 second while I bring up TBC.
Yeah, and Riley, to that point that you made in a couple slides ago, you started to talk about how people are starting to use scanners in tunneling. Can you kind of talk about the difference between using the S9 and the scanners? We had a question come in from Thomas that said, "Why are you using the SX10?"
Yeah, so great question, Thomas. Thank you for asking it. So both have their uses in a tunnel. So the S series total stations to me are I would call them the workhorse. They do a lot of the staking, the general data collection, and really your go-to instrument. And the reason why I'm using it in this particular demo is when you're in NATEM tunnels, you're doing a lot of stakeout of key features, so things like rock anchors, blast holes, and all that. And one thing that is essentially critical is to have a laser pointer, and that's essentially why I'm using the S9 today. Now, that's not to say you couldn't use the SX10 for the exact same thing. The only challenge is the SX10 doesn't have a laser pointer. Now, on the flip side of that, the SX10 is really useful for, well, it can do all of those other things. It can do set out, it can do some as-built collection, but it's got, of course, the scanning and the imaging capabilities. And so if you want to collect more rich detail on understanding volumes, like things for how much material was removed, how much shotcrete was sprayed, or if you're doing an as-built on kind of the final tunnel lining and just doing that across the whole tunnel to provide, which is quite a common deliverable in tunnel projects now, is of kind of a finished as-built scan data set. And then a much more useful tool in that case, first of all, for the higher detailed scanning that's available in the SX10, and the ability to have those geo-referenced point clouds based on the survey control that's already going to be in a tunnel. So kind of two sides to that equation. So I hope I answered the question. If not, Thomas, feel free to put back in the chat and I'll get to it again. So getting into the demo. So we're going to start in TBC. What I've got here is a design alignment. I've already created it to kind of save us some time from creating that alignment. So you can see that here on the right-hand side. Now, if I just give you an idea, if I pop up the tunnel editor, you can see that it's kind of a straightforward alignment. We've got some lines, arcs, spiral arcs, as well as some vertical curve and gradients. So standard alignment. Now, where do we go from here? Well, we're going to go to the Tunnels tab in TBC. And I really like the layout of this because essentially you progress from left-hand to right-hand side in a workflow sense. So we've got our tunnel alignment. You could also edit the alignment and create labels for that alignment as well. What we're going to start with is creating actual tunnel design. So first you create a tunnel corridor, which I like to think of as kind of a container for tunnel design. So if you have multiple tunnel designs, for instance, if you had a northbound tunnel and a southbound tunnel, you could put both of those in one corridor, and that would be kind of the primary use for it. So we'll start by naming that corridor. We've already got our alignment selected. Press OK. And then the next thing is to create the tunnel design. And you'll see on the left-hand side, as we go through creating the tunnel design elements, that they'll populate in the Project Explorer tree over here. So for the tunnel design, we'll call this northbound. Kind of looks like we're going in a northbound direction-ish with this alignment. And then we'll select our corridor and then a station interval. So this will be how often along the alignment we're going to populate our template once we create it. So we'll go with 10 meters. That's probably more than enough. This template alignment method is quite important. So what this is doing is how the cross section or the template of the tunnel shape is applied relative to the alignment. And why I say that's important is if you have steep grades on your alignment, you're typically going to want to use the perpendicular option, because that's going to apply the shape always perpendicular to the alignment. So for instance, if your alignment's at a really steep grade, it's always going to be applied perpendicular, as opposed to vertical, which will be kind of in plumb line. And there's cases for both, so we have both options in TBC. In this case, I'm going to use the perpendicular option and press OK. And now we've got our tunnel. Now we need to create the necessary geometry for that tunnel. So first we got to create a template. Once again, templates are kind of like a container for all of the different geometry shapes. So you may have multiple shapes, which I'll get into after this. So we'll just call it template 1. If you had an existing one, you could copy it. And we'll just put this right at the start. So you can either type that station in or you can snap to it here. So I'm just going to click, and that pulls up the station already. And OK. And now we've got our tunnel shape. So this is the geometry. If you're familiar with corridors in TBC, this is like your cross section. This is essentially the same thing. You're defining how that shape looks. And you might have multiple shapes. So in that template, you might have 1, 2, 3 shapes. And why that's important is shape 1 might be your outer diameter, your excavated surface. And shape 2 might be the inner diameter. It might be finished lining. It might be shotcrete surface. Could be a variety of different things. So let's just call this outer diameter for now. And once again, if I had an existing shape, I could copy it, but I don't. So we're going to go from scratch. Now, a lot of the time you might be just given a stack of plans with kind of all of this information on it and not have a design. So this is where using these tools in TBC is really, really helpful to get this data prepped, ready to take out to Trimble Access. So you can take, some of you may or may not know, if you're power users of TBC, you probably know this, but you can drag views around in TBC. So I'm going to drag the shape editor here up to the top, and I'll just close the plan view. So now I've got a bigger area to work with here. So first, the view at the top is our essentially our cross-section view, and so we're going to add elements. So we're going to start with a start point, and I've got some notes here that I'm going to follow of what kind of design I want. So we're going to start by creating a start point, and you'll see that populate here in this view as we go through. So the first thing I'm going to do is a line. And there's a variety of different options here for creating different geometry elements for the design. So I'm going to use kind of a simpler one, but line, elevation, and offset. So in this case, let's see, I'm going to go -0.5 and create that. And now you'll see automatically here is that line created in the view. So I'm going to go ahead and create some more elements. Might be a good time. I don't know if there's been any questions, Jeff, but if there has been any, feel free to pop those up and I can answer those while I do these here.
Yeah, we had one other question, but I'm waiting for some more detail around it. So
Sure.
when that comes in, I'll go ahead and ask.
All right.
We did have another question come in from Hassan. Does TBC have a module for deformation monitoring? The answer to that is not at the moment. Good question though.
I think we all want to see it, Hassan, so I agree with you. All right, and then here's the last point to finish off our tunnel design. All right, so kind of what I would call maybe a standard horseshoe shaped type tunnel design. So we've got all those elements keyed in. We can kind of view that before we do anything else. So awesome, we've got that tunnel shape ready. The next thing we can do is visualize that in 3D. So here we've got the design tunnel mesh tool. So click on that. And you select your tunnel shape and you give it a name. I'm going to call it outer diameter. If we want, we could put it on a layer. One thing you might not know is if you press spacebar, it'll automatically bring up that layer manager. It's kind of a tip and trick in TBC that I like to use. And let's give it a fancy color so we see it well. All right, and then once you have that in, you press OK. And you're not going to be able to see this because I don't have a view open, but that's fine. So at the top, we're going to click the 3D view. And now you'll notice we've got kind of a 3D mesh of our tunnel design. So it's taking that shape, it's taken the alignment and created a 3D mesh along the whole alignment. And you can see that in any of the views, plan view, 3D view, station view, they're all there. So next, what I'm going to cover is a workflow that is more prevalent in NATEM tunnels, which is set out point. So these would be key features like blast holes. They would be set out points for rock anchors, so reinforcing the sides of the tunnel. They're really similar in a sense to stakeout points, if in the same kind of terminology, but set out points are more for tunnel specific workflows. So in TBC, we've got this edit setouts. So I'll hit that. And then what that'll do is open up another cool thing, which is the tunnel view. And if you're familiar with the TBC tunneling module in the latest version of TBC, which is 5.3, did some updates to the tunnel view to kind of make it a more comprehensive way to view all of your designs, shapes, set out points, offsets, rotations, all in one kind of centralized view. And so I'm going to go through that and you'll see some of the new things as I do. So on the left-hand side, there's options for the shape. So if I click on shape, you'll see that existing shape that I've already created. But what I want to do is do the set out points. So there's essentially 4 different types. The radial is especially used for rock anchors. So you're essentially projecting out an offset based on the center point radial out to meet the tunnel design. You'll see what I mean when I enter that point. So let's start with that. We'll go radial. You put in a start station and an end station. So if you wanted this to be applied at a range of stations, you could do that. In this case, I'll just put it at 1 for demo's sake. And then you apply the offsets. So let's see, I've got some offsets here. You could also offset that center point, which the radial will be projected out from. In this case, I'll leave it at 0. And then the last thing you need is a shape. So I'll select my outer diameter shape and see it's computing that. Now, I don't see anything right now, but that's because it's at station 1200. So I can do that by using the slider here, the bottom, and that'll go through all the tunnel. But I want to input that station. So let's go 1200 there. And now you'll see that point here. And that's the radial setup point that I've created. And so it's essentially gone from this alignment and projected it out at that offset to meet the tunnel design. Next type we'll look at is the horizontal. So same thing, put in some stationing, and it only requires a vertical offset here and then a direction. So is going on left of the alignment or right of the alignment. So let's do left and then the shape. And now if I tab to the next one, you'll see that's created. So as it sounds horizontal, it's instead of projecting out radial, it's projecting out horizontally in that direction. Likewise, there's a vertical. So kind of the same principle. It's going to project that out in a vertical manner. So I'm going to have this one project up, and now we've got a vertical plane as well. And then the last one, which I think is quite common, especially in NATEM tunnels when you're marking out blast holes on the tunnel face. Same process. You enter a had some issues there. Start station, end station, and the proper offsets. And you don't need a shape for this one because it's just going to strictly apply that to kind of the tunnel center. Oop, looks like I'm missing it somewhere. Let me try and create that one again. Technical difficulties. Cool. And so there's a blast hole right there that you can see. So you can keep editing and adding more and more of these if you need. And typically, if you're doing blast holes, you'll have several, whether it's 10 or more, depending on the tunnel size and shape, and as well as the geology. The other thing that I want to go over with the tunnel view is applying rotations and offsets. So on the left-hand side, we'll go to that. This can be quite common, especially if you want to offset multiple designs. You have one alignment, but let's say you have two designs, one on each side. You can use offsets to do that. So in this case, I'm going to apply a pretty simple one. We'll just apply a 0.1 offset horizontal, and notice here that now the alignment is offset 0.1 to the right. You could do the same thing as well with the vertical. Right now we've got that alignment moved up 0.1. Rotations are really interesting. They're similar to a super elevation, but not the same as a super elevation. What they're doing is rotating the tunnel shape at whatever rotation and station that you choose. So for instance, let's put in a station. We'll say at station 1200, it's going to be at 0 degrees rotation, but by, let's say, station 1350, we're going to hit 5 degrees. And now, actually, I'll keep entering the elements. I've got a couple more. I want to go that 5 degrees until that station. And then we'll go back to 0 degrees rotation. It's the wrong station. 0 degrees rotation here. Cool. So now with the little slider bar, I can see kind of how that looks. You'll notice as I slide across that design, tilts 5 degrees, and then it'll tilt back. So the reason I show that is quite common, especially in metro or road tunnels where you have to rotate along curves to counteract those forces going at speed. All right, so we've got the setouts, we've got our offsets, our rotations. The one last thing I'd like to cover before we get into the field aspect is multiple shapes. So in this case, we've got one shape, but let's say you wanted an inner diameter surface. We can call it the shotcrete, we can call it the tunnel lining. Easy way, you can go to the Create Shape menu, and you can create another one. We'll call it inner diameter, and use this copy shape function. So I can select any existing shape. So we'll use the outer diameter and just apply an offset. So if I know that thickness of shotcrete is going to be, let's say 0.1, I can put negative 0.1 offset and hit OK. Excuse me. And now in the tunnel view, we've got our both shapes. Here, let me close that shape editor. In the tunnel view, we've got both shapes, the inner and outer diameter. And likewise, you could create a design mesh for that inner diameter as well. So I can press OK, create that, and now if I blow up the 3D view here, they're the same color, but let's change one of these to make it a little more clear. You have both shapes. So you have multiple shapes in a tunnel design. All right, so we've got all of our tunnel design, data prepped, all of that ready to go for the field. The last step is to get that out in a format. So we've got an export format between Trimble Access and TBC called the TXL, or Trimble Tunnel XML design template. So here under the export menu under corridor, you'll see the TXL tunnel exporter. You select all the necessary information and then export out, and you'll have that .txl file, and then you can bring that into Trimble Access. So we're ready to go into the field portion of this. Before we do, just to break up things, in case anyone's fallen asleep, we're gonna throw up a second poll question. Jeff, if you could do that now, please.
Hopefully everybody can see that. We've had some votes come in a little earlier, but
Cool.
the more the merrier. We had a question come in from another person. Give me a minute. Can you quickly show how to edit or delete an entry to your design? So I think maybe starting out right at the first station, you can make some of those edits.
In TBC or Trimble Access?
He did not clarify, but I'm guessing TBC.
If it's TBC, it's like any other element in TBC. So you can, if you want to delete any of the templates or the shapes or any of that information, you can go and right click and delete that information. If you're looking at, let's say, removing a certain element in the tunnel, like I've got all these design elements, I can go here, right click and delete that row, and I'll get rid of that that piece of geometry. So that if there's something else you're referring to, please just clarify in the chat window, and I can go back and look at that. All right.
Thanks,
so.
Brandon.
All right, so I think we've probably had time to answer the poll. Looks like a good chunk of you, about half, have never seen Trimble Access tunnels, which is awesome. So I hope that's why you're on the call today. So I'm gonna give you a run through of that right now. So you can probably see if my webcam is still operating. I've got a S9 set up here, connected to Trimble Access, and we've got that tunnel design. You can see that here, and I've got the total station set up with the kind of a simple backsite setup. And I'll be using the laser pointer today, no prism. And so I've got it pointing kind of at my wall here in this room. So if you're not familiar, in Trimble Access, we've got several different modules that you can use aside from the general survey, which is the one that most people are familiar with. And the one we're going to cover today is tunnels. So in tunnels, we have essentially 5 categories of features. We have the define, which we'll go into first, which is more of looking at the design information. And then with the survey tasks, machine positioning, which is used for, let's say you're positioning a drilling jumbo, reviewing any of the data that's been collected, and then reporting on that as well. So jumping in right away, we're gonna look at the define. So the cool thing about this is you can create a design in essentially the same way you did in TBC as in Trimble Access, and you can transfer that data using the TXL format between the two. So in this case, I've got the similar design that we created in TBC here in Trimble Access, and I can click on that, and it's got all of those elements. So I can look at the horizontal alignment and see all of the lines, the arcs, the curves. If I want to edit any of those pieces of information, I can click edit and add that. So a really useful tool, especially if you're in the field and you need to change or things are revised on the go. You can do it in Trimble Access without having to crack open your laptop and open TBC. And it's got all of the other information like setouts, alignments, basically anything that we created in TBC will be there. So the next part we'll go into is the actual survey piece. So we've got a few functions that are very familiar in other pieces of Trimble Access, like the measure surface, station elevation. So I won't go into those for this video. I'm going to go into the more tunnel specific ones. So that's these 3 here: auto scan, position in tunnel, and setout. So let's start with the setout. That's essentially the logical step. You're going to be setting up blast holes for the excavation. You might be doing rock anchors for support. So you select the TXL, so you could have multiple TXLs with different points and different designs. And then you define a station range In this case, I know I've got some set out points at station 1200. So I'm going to put that in. I could also put in the interval. So let's say at every 1, 5, 10 meters, I want to set up those points. I could put that in. In this case, for time's sake, we're only going to do one interval. I know, disappointing, but nonetheless, we're going to get into it. So first, there's two views in the setup menu. There's a kind of a plan view looking down on the alignment. So I'll zoom out a bit, and you'll see how the dotted red line is where the total station is looking. So if I move this a little bit, you'll see it updates. And then the green line is the offset alignment. Remember, we had an offset in our design, and the black line is that the original position of that alignment. And so you'll see we're pretty close to station 1200. In the bottom right, there's a little cross-section view, so I'm going to click that. Now that shows the tunnel. So it's showing, first of all, both of the designs, but also showing all the setup points. So for instance, I want to click on this blast hole right here. You'll notice this black cross, I'm going to move it, is where the total station is pointing. So it's taking measurements right now, positioning itself relative to the tunnel design. So now if I click on that blast hole, I'm going to use this auto feature here. So if I click that, it's going to ask me for a tolerance. So this is, I'm setting out the points, excuse me, what accuracy do they need to be set out to? Or not what accuracy, but what tolerance relative to design do they need to be set out to? Then I can press accept. And then we've got some settings for setting out points. So we put in a start point. I can call it whatever I want. I can call it Riley's point number 1. I can call it 20,000. The EDM timeout is pretty important. So what this is doing is it will measure for 30 seconds, and if it doesn't get a return in that time period, it's going to move on to the next point or finish up. And why this is important is sometimes you might be measuring to a really fine corner, or the surface may be really wet, or just hard to get a good EDM return on. So you want to have that on. So first of all, you know that you missed the point, but also that you're not waiting forever for it to measure something. So usually, 5 seconds is probably more than enough. This auto set out details is really important. When you're setting up points, especially blast holes, you could be by yourself. You might want a kind of automated way of setting out those points. So what this does is puts delays on kind of both ends of the measurement process. First, the total station will point to the location of the setup point, and it'll give you a delay. So the surveyor can walk up and mark out with spray paint or whatever it is on that face of the wall, and that start delay gives them time to mark it out and then move on to the next point before the total station actually turns. So kind of an automated way of both marking out and getting the position from the total station. So you can have those set up. There's also some other options here, cross-section guidelines for kind of visualizing in the cross-section view, but we won't get into those now. Press enter, accept. Cool, and you'll notice that little black cross there automatically turned to the position. So now the total station's measuring, and once it knows it's at the location, it's gonna first of all audio and visually say mark point. So you see that here in the bottom right-hand side. And so I can store that position of that point. If I had multiple points, it would move on to the next ones and so forth. But in this case, I only have one blast hole. So I'll store. Oops. All right, so that's the setup feature, and now I could set out any of those other points, but for time's sake, we won't do it in this demo. Let's go back to the main menu, and we're going to go into the next feature, which is auto scan. This is personally one of my favorites. So this is a semi-automated way of collecting profiles along the tunnel design. So common use case, all the material has been excavated. We need to know how much was removed and if there's proper over and under break. And if you're not familiar with over and under break, it's very similar to cut and fill. It's essentially over break is how much more outside of the design we excavated, and under break is how much we didn't get excavated to the design, so how much more we need to actually excavate. So instead of putting in a station range, I'm going to just hit the measure button, and the total station will take a measurement and give me the station where I'm at. So I'll use that station. And once again, we're only going to do one interval, but if you wanted to measure, let's say every 1 meter, 20 meters either side of the instrument, you could do that. And then the last thing is to specify a surface. So we could choose inner, outer diameter. In this case, I think let's go with outer diameter. Once again, we've got the plan and cross-section view. So if we go to the cross-section view, same thing. So in this case, you'll see that you'll see that black cross, which is the total station, you might even be able to see it behind me moving and turning to that position. And I can see kind of on those key points where we're relying if it's going to be over and under break. But the real power here is using the actual auto scan. So first we'll hit start. And before you can ever get into this, you need to specify the settings. Once you've got the settings specified, every time you hit auto scan, it's just going to run through the auto scan based on the last settings. And if you want to change those, I'll show how to do that in a minute. So first, like always, we need to specify point range. If you want to use a code, you could. I've got a feature library in here, but in this case, I don't really need them, but the option is there. The scan interval defines how many points along that shape you'll be measuring. So in this case, every half a meter, I'm going to measure a point, which is probably more than enough. And then I'm going to have a EDM timeout. I'll change it to 5 seconds. This last piece I'll cover in the settings is the auto scan on station adjustment. So this makes adjustments for the total station's position. If it's not directly perpendicular to the surface, it'll adjust relative to that station. So it'll measure and then adjust the total station position to get it on the right station. All right, and then we need the tolerances. So this will be for the station as well as the overbreak and underbreak. Let's see, I'm gonna set, let's say 5 centimeters for the over and underbreak, and then press enter. So you'll notice as soon as I hit accept, the total station is gonna start measuring. So it's gonna start on that first point. You can probably see it behind me here. It'll measure. Once it gets a point measured, it's gonna move on to the next one. And you'll see it creates points as it goes. So that green means it's within the tolerances that we set. So that 5 centimeters that I set before. So it's gonna go along and measure the wall surface here. And hopefully maybe we'll hit some underbreak or overbreak so you get an idea of how that looks in Trimble Access. You'll notice at the bottom here we have this this kind of data tab where it's showing the underbreak or overbreak values in delta relative to that station that we selected. So I think this point will hopefully be overbreak or underbreak. It's going to hit a little cabinet here in my room. We'll see if it gets there. Cool. So once that profile is done being measured, it's going to come up with a results page. In this case, it says errors. So the reason it says errors is either points were skipped or points were outside of tolerance. In this case, a point was skipped, probably because it ran into that issue there, or that counter I had there. So what we can do is, now that we know that there's a point skipped, I can look over here and say, okay, that was the point that was missed. And if I want to, let's say, direct the construction crew to that specific point, I can click, and now the total station will point and use the laser pointer to notify that location. So that's the auto scan in a nutshell. If you click and hold on the menu here, that'll bring up a variety of different features. So there's a way to just manually measure. So if I wanted to measure a point, let's say right here, I'll move it over a bit so it's not on that corner. I can store, and it'll measure a point in that location. So if I just want to collect some more points along the profile, I can do that. If I go back to the auto scan, there's also the scan zone. So let's say there's which is common in tunnels is to have a big ductwork running down the top of it, and I don't want to scan that because it's just going to ruin my profiles. I can add a scan zone, and that'll allow me to point the total station in 2 areas to define where I actually want to scan. So I hit scan zone. In this case, let's say I want to measure just on the left-hand side. So I'll press accept for the first point, and then it asks me for the end of the scan zone, and then I can point it to kind of a second location, press accept. Now between those 2 total station positions is where it's going to scan and nowhere else. And you can have multiple scan zones as well. So that's the auto scan feature. Going back to the main menu, let's see, we're running out of time, so I'm getting too excited about Trimble Access Tunnels, so I'm gonna try and tidy this one up and go back into TBC. So the last one is position in tunnel. This is essentially a really simple but powerful feature. It's giving you the position of the instrument or wherever you're measuring relative to the tunnel design. So you'll see as I turn the total station, it's updating all of those values relative to the tunnel design here. And I can tab over here on the bottom to show different values if I want to understand the horizontal vertical offsets, if there's a rotation there, or if I'm just looking for standard coordinates. So all that information is available. And then I can just store those as regular points here. All right. The machine positioning, next thing I'm going to, is typically used for positioning drilling jumbos. So if you're drilling into the face of the tunnel, you would provide a tunnel face. I'll just hit measure, and that'll get me a station of the tunnel face. And then the drill depth. So if I'm drilling to, let's say, 4 meters, press enter, and what it's going to do is create a reference line based on that information. So the design, the station, and the drill depth. Now when I hit next, oops, I jumped too far. Let me go back to that. Machine positioning, getting too excited. Measure, and then drill depth. When I press next, this is essentially the machine positioning screen. So it's going to give you 3 offsets. It's going to give you longitudinal, which is forward, backward along the alignment. It's going to give you vertical, up and down relative to the alignment, and transverse, left, right. And if there's a construction offset necessary, for whatever reason, that's there. But you'll see as I move the total station, these values change. So if I wanted to change the try and get it closer to, 0, I could move it over, and then we're getting kind of in the area. It's a pretty straightforward feature, but nonetheless powerful. All right, so finish that up. So we've done all the data collection, we positioned the machines. The last 2 things is kind of reviewing the data and reporting on it. So if we go to review and we click on one of these stations, we can select a station here. So I've measured at 2 stations. I did the set out point at one, and I did the auto scan at the other. So if I click the auto scan one, press accept, and go to results, I can look at all of those scan points. Doesn't really give me a lot of detail, but it tells me how many were measured. Now, if we go into this menu, I can get that cross-section view of the data again. So if I want to go back and see anything, I can. There's also a same thing, kind of a click and hold menu to select different things. And as well, if I want to get the details, this will give me a more descriptive analysis of what was collected. So if I look at this point, I can see the grid coordinates, I can see the underbreak, station delta, and a variety of other information. Last piece is the reports. So there's a few different reports in here. One of my favorites is the tunnel profile detail report. And I'll click on that view creative file and press accept. And that should pop up. Kind of a simple, but you might need it anyways in the field. You know, if you have to report immediately something to contractor, whoever it is, then you can quickly generate this report in Trimble Access, which will give you the underbreak, overbreak, and the station values as well. All right, so we've covered all of that in Trimble Access. Now let's go back to TBC where we've brought that job file from Trimble Access back into TBC. So we've still got our tunnel design. I labeled the alignment here with some station values, but I imported that job file, so I've got some as-built points in here. The reason why I want to show this is to kind of close off the workflow. We've done the data prep design work, we've done the in-field staking, as-built collection, and now back in the office, I want to do a little bit more, let's say, complex analysis. So we want what is probably one of the primary deliverables on most NAME projects for the surveyor, which is the as-built or the over and under break report. So the first thing that we need to do is assign tunnel points. Now, why this is important is we're assigning data to I'm just going to remove these. Looks like I already did it accidentally. We're signing data to the signing as-built points to the design. So when we do the report, it has only those specific points associated to the overbreak and underbreak. But why that's cool is under the selection method, there's a few different ways of doing that. So in this case, we're going to use job file, which is the simplest, more straightforward, especially if you're using total station data. But let's say you're using an SX10 or an X7 and you've got a scan data of that surface, then you could also do it from a point cloud. In this case, I don't have it, but just for example's sake, you can specify all of this information, such as which point cloud, in the search distance. So essentially it's sampling out that point cloud to take a point every 0.5 meters at this interval. So essentially doing the same as-builting with scan data as you would with a total station. So some flexibility on how you want to do that. In this case, we're going to use the total station data. So what I'll do is just press add. And what it's going to do is rip all of those points from the job file into into this little graph and show them here. In this case, I've got two profiles I've scanned. Here, it shows all the points. If I wanted to remove any of those points, let's say one was just out to lunch, it would hit a dozer or something moving by, I can right-click on it and remove and click delete, and that'll remove the point. So once I've got all those set, I press OK, and it'll add those to the tunnel. And now to create the report, I can go to Tunnel As Built and run the Tunnel As Built report. One thing that I think is really powerful is the custom report. So if you want to tailor the overbreak, underbreak, as built report to your specific requirements, maybe there's some information in it that you don't need, or you need to add some, or you want to add a logo, whatever it is, you can use the custom report feature, and that'll allow you to edit the report template in Microsoft Word and use that in future reporting scenarios. So in this case, I do have one that I've created, which is shown here. We're just going to use the standard one. So we'll run tunnel as built report. We'll select the tunnel and which points we want to use, and then the tolerances. So I've got some tight tolerances here just because I want to show what overbreak and underbreak looks like. And you can change the colors of what overbreak and underbreak will look like. So once we're happy with those settings, I usually go with the defaults in most cases other than the tolerances. I'll hit OK, and that will run the report and then open it in Microsoft Word, except it opened it on my other monitor. So just let me drag that over. All right, so here's the as-built report. So on the right-hand side, we have some data about that specific cross-section. So what's the coordinates of it? What station is it at? The settings, some of the computations, so areas, circumference, all of that data here. And then on the left-hand side is a graphical view of that overbreak, underbreak. Some really good information there. The yellow or orange values, however you look at that, is any points that were out of the station tolerance. Now, if they were red, they are outside the overbreak and underbreak tolerance. And so you can see that when I scroll down, you'll see those points are highlighted in red here. The station delta is out of tolerance in that list. Now, if you had multiple as-built profiles, it would create one of these, a set of these 2 pages for each profile automatically. In this case, I only have one. And it would also calculate areas and volumes. In this case, I'm not getting any volumes because I only have one profile, but if I had multiple, it would create the volumes between those profiles. Cool. We've got 5 minutes left, so I think with that, I'm going to finish it off. The last thing I'll say, I didn't get much time to get into this, and maybe if there's a outcry and people want to see it, we'll do another webinar in the future, but tunnel designs and tunnel data in TBC are also supported with the drafting module. So for instance, if you want to create cross-section sheets of a design, let's say, I'm just going to try and pull up a quick example. Both cross-section, plan, profile, any of those types of drafting templates can be applied to a tunnel as well. So I just built the sheets, and we'll take a quick look at what that looks like. So for instance, if you wanted to have your own sheet set, you wanted to apply a template to it and all that, you could create that in the drafting piece of TBC as well. So it's got a lot of that similar information. We've got a point table. We've got the design showing the overbreak and underbreak here as well. And so with that, I think we'll move back to the presentation. Let me just pull that up. I needed a reverse one of Mario coming out of the tunnel here. All right, so whoops, go back to present. So with that, so we're going to move on to, I hope everybody has some questions, so feel free right now to put those in the chat if you haven't, while Jeff and I go over kind of some next steps and resources for everyone on the call. So from my side, we've just created a new YouTube channel for Trimble tunneling products, so feel free to go check it out. You can either type in Trimble tunneling solutions in YouTube or go to that link there. And a lot of the material right now is tutorial videos, and we're probably going to keep adding more and more of those as we go. There's quite a few for both Trimble Access Tunnels and TBC tunneling. Pretty much for any feature in those two softwares we've covered a video of, so definitely some good resources to cover. And feel free, if you're interested in finding more about tunneling surveying, or you want to talk more about Trimble Access or TBC, feel free to reach out to me after this. You can connect with me on LinkedIn. I'm pretty easy to find, and I'd love to hear from all of you. And with that, I'll let Jeff cover the rest of this.
Thanks, Riley. I'll try to cover this really quick, guys, because I want to get some of your questions answered. So I might fly through these a little bit, but these are all available online for you guys to come in and view this slide deck afterwards. If you have any questions, just reach out to Riley and I later on. So I just really quickly want to direct you to the TBC Geospatial webpage. This is a great, host for all this information. Whether it be the latest version download, the what's new. Blog, just to show off, what and encapsulate what's in each version. We've also got product bulletins and support notes, a vast majority of tutorials and links to the previous webinars, such as this one, all on demand for free. Go to the next slide. So as I mentioned earlier, we've got the TBC tutorials on the webpage. Currently, there's over 40 of these guys right now. So if you guys want to go in and learn a specific workflow, we provide the data sets and the instructions to do so. So please check that out.
I'll say that there's some really good tunneling tutorials in there as well.
Yep. As Riley mentioned, Trimble does a good job of making some videos available on YouTube, so please check out the TBC Survey and Construction channel. Right now, I think we have over 30 workflow-based playlists, so over 300 videos in total. So go in there and learn and troubleshoot as needed. And then also we have every single monthly Power Hour posted on the webinars link. So come in here and check out each one for free. These are all available and archived for everyone to check out. So the TBC tips page, this is a really good way to come in and learn quick tips and tricks about TBC. We post usually every Friday. Our wonderful interns monitor this page, and there's over 100 tips and counting right now. So check that out and learn some quick things about TBC. We also have the TBC community page for geospatial. So this is a great way to come in and use it as a blog for news and post your questions, create some forum topics, and really talk amongst your peers and see how other people are using Business Center today. TBC news and notifications. As you may have noticed already, when you fire up TBC, we have a news section on the right-hand side. This is a great way to stay, up to date with the product and download any updates that you need, such as a new coordinate system manager or some new things in TBC as needed. So check that out and keep an eye on it, please. We also have the Trimble Geospatial Help Portal. This is a great starting point for all TBC or other Trimble Geospatial product resources. It's a nice homepage or bookmark for you guys. And then, like as mentioned before with the geospatial, we have the construction community page as well to just kind of come in and post some content, chat amongst your peers and see how other people are using Business Center today. So two sides of the business there for the community. Let's see, we also have the macros community pages, so come in here and see what's available to drop into TBC, especially if you know how to program in Python. This is a good page to come in and check out, see what's already been made and maybe build off of that in the future. Some of the next steps is to download the new version of TBC 530 released just a while ago. If you don't know where your local distribution partner is, please use this link provided here, and you can zoom into the nearest location and talk to your distribution partner. So the next TBC Power Hour is June 24th, 8 a.m. Mountain Time again. We'll be having Joe Hicks with Conaway Geomatics Inc. He'll basically be walking through these new tools and functionality of the CAD command line that we just released in 530. You'll see how his company is utilizing this on a day-to-day basis and really, gaining and maximizing productivity within Trimble Business Center. It's a really nice ad, and we're really looking forward to showing you guys this feature off. With that being said, we'll hop into the questions. I know there's some good ones that came in.
Cool. Yeah, I did have a comment about not being able to see my screen, so I hope most people were able to see it. If not, we can definitely think of ways how we can get the presentation to you folks after.
Yeah, I think it was showing for the most part. I had one gentleman that tried it again, and it was just a switch of the setting, so he was
Cool.
good.
All right, let's see if we can get to some. There's a lot of good ones, and I appreciate the feedback from everybody. So let's see. There was one question, and actually, it would be great if we get some clarification on what exactly we're looking for. But the question is more information on TBC for long curve pipe jacking. So I guess if you could provide some additional information on what exactly you're planning to use TBC for in long curve pipe jacking. What I'll say is just to inform everyone. So with pipe jacking, long curve pipe jacking, you've got these sections of tunnel that are being built around a curve, and so in TBC, the simple way to put it is you can design and input any of that data from the official design for that tunnel to do the data prep. So just like we were doing today, you can input the alignment. You could import it from a CAD file. So if your alignment came in from DXF, you could import that, and you can define the shape of the tunnel, no problem, and all that information. A lot of the time with pipe jacking, those are there's typically not an intensive survey done for those unless they're really large diameter, but there is a lot of times survey done to align and monitor the position of whether it's a laser guided system or other type of system guiding that machine that's doing the pipe jacking. And that's one of the bigger workflows. But if there's something you specifically want or are interested in pipe jacking, just feel free to put that in the chat and I can take a stab at it. So let's see, any other questions? Yeah, let's see.
Yeah, we had one. Can you import the design into Civil 3D?
Short answer is yes, you can. So you can export from TBC in any of those common CAD formats, DXF, DWG. You can export the alignments, but you can also export the 3D mesh as well. So if you want either of those to go into CAD. Also, I was showing, excuse me, the drafting functionality in TBC. You can export those sheets out in CAD or PDF. So those could go.
And that's a good point, Riley. I would recommend checking out some of the drafting capabilities before shipping that out to Autodesk, especially with the new CAD command line and some of the functionality we just put in there. And hopefully, that suits your workflow and you can keep it all into TBC.
Great.
There was another one that came in.
Yeah, go ahead.
Oh, go ahead. I thought this was an interesting question. Is there any geometry or fixed points where you should set out targets within tunnels and mount them?
Yeah, it's a complex question because there's for the control surveyor in a tunnel, how many targets and where you set them is, I think, probably one of the biggest challenges. The recommended type of traverse that's run through tunnels is typically a double braced, I think this is the technical term, double braced traverse, where you're essentially zigzagging through the tunnel and having a redundant measurement in each setup. And the idea behind that is you have a lot of issues on a long linear tunnel with EDM refraction, so you want to try and mitigate that with this zigzag methodology. So that's one thing you want to take into account. Line of sight is always a big thing in tunnels, so you want to consider that. You don't want to, I mean, with any control survey, you don't want the control to be too far apart. You don't want it to be too short as well. And so there's a lot of, I could do a whole webinar, and maybe will one day, on just the control, the whole workflow for control surveys and tunnels. So it's a broad question, but that's how I'll answer it. There's one that's related that I just saw come up here about the testing the breakthrough precision. So for anyone who's not familiar, breakthrough is essentially if you have two tunnels, or you have one tunnel and you're constructing from both sides, so you have two machines working towards to meet in the middle somewhere. You have this what's called a break point, and that's the point at which those two traverses are going to line up. And I mean, it's never going to be zero, so you have some type of tolerance there which you're trying to meet. And there's no specific, I would say, no specific feature in TBC that's designated breakpoint analysis, but you can do a lot of the network adjustment on data. So you can bring all of your traverse, your GNSS, whatever it is you're using for control, and bring that into TBC and do the adjustments necessary. One thing that's cool about doing the adjustments in TBC, if you're any of you doing tunnel surveys are using gyroscopes, you can take that azimuth that's provided by the gyroscope and put it into TBC network adjustment as an azimuth constraint to improve your tunnel network.
Awesome.
Some great questions here. I'm just trying to see which ones to attack first. What are we? We have probably a time for at least one more, I would say.
Yeah, so this is another one that came in. Can we import alignments in text, XML, or DXF format? I think we covered that a little bit, but.
Yes, you simple answer is yes, you can import alignments into TBC. And I would definitely recommend it if you have an alignment to start off with. It's always easier to use straight from the designer or the engineer to import that data in. This one was a good question, and I think it's cool just because I'm a fan of the application. But regarding sight vision, so if anyone's not familiar with sight vision, it's a product made by Trimble, basically high accuracy augmented reality outdoors. And the question is, can we essentially bring tunnel designs into sight vision and use them? So short answer is yes. I think we have some improvements we can make there. Right now, the way to do that is exporting that tunnel mesh as a CAD file, a DXF, and importing it into sight vision. I would like to see it be a little more comprehensive in using the TXL format, and maybe we'll get there one day. But short answer is yes, you can do it. And I would like, if anyone's done it, yeah, definitely send me some pictures or anything about it, because I would love to see it. Unfortunately, with the quarantine, I haven't been able to get in as many tunnels as I would like to test that out. But for sure, I think that's a great question.
I would also recommend trying out the Sight Vision AR exporter as well that we have as an export function.
Great. Yeah, cool. Cool.
I think we have all the questions answered.
For the most part, I think there's a few more, but I think we've already taken about 10 minutes over time. So what I'll do is after you close out this webinar, there's a feedback survey. If anyone has any questions or you want to chat with me, just put a note in there. Feel free to reach out. I'd love to talk about tunneling with anyone who's interested. So thanks again, Jeff, and everyone for having me on. I really like presenting these power hours, and I'm glad to do it again after a few years hiatus.
Yeah, thank you, Riley. I think you covered some great material. It was very comprehensive. We may have to do a follow-up. I think this was very well received, and there's still some more things we could have talked about. So we might have a part 2 here coming up.
Cool. Awesome.
Thanks everybody for joining. We hope you enjoyed it.
Cool. See you, everyone. Take care.